We will look at decision trees in the context of location decisions. Keep in mind that decision trees are a general approach in decision making. They are not only focused on making location decisions. I'm sure you will discuss decision trees in the other course in decision theory, but here we look at decision trees in the context of location decisions only. So when to use a decision tree? When is it appropriate to use this method? We want to evaluate a couple of interdependent decisions. And interdependent means that the decisions depend on each other. Think of it, for example, as choosing courses at GeoTech in your program. And for some courses, you might not be sure if you're able to pass them. However, in the future, you need some of the courses as prerequisites to join other courses. And you have to make a couple of decisions when to take which course. And these decisions are made in sequence. Of course, for the first semester, you plan your first semester courses, then half a year later, you plan your second semester courses. But the available courses might depend on courses that you were able to pass in the first semester because of prerequisites. And of course, the main ingredient in decision trees, that it is the main reason why you want to use them is that the future events, the future data is uncertain. You are not 100% sure about how the situation in the future will look like. When we look at the example of capacity expansion, then in order to make this decision, we need to know what will be the future demand of our customers in order to expand our capacity. Let's assume we have two options. We can either build a small factory, or we can build a large factory. We are not looking at the option of doing nothing. So either we go for the large factory or we go for the small factory. And what is best depends on how the future demand will look like. We have to decide today if we go for the large or the small factory, and in the future we can decide again. For example, in 3 years we look again at the current demand and our expectations, and in the case we built a small factory, we can still upgrade the small factory to a large factory. On the other hand, if we decided to go for a large factory from the beginning, then we cannot do another decision. So the benefit of doing it step by step, expanding the capacity, is that we have more clarity about the future demand of our customers. And on the other hand, the negative sides of doing it step by step is that this will usually be much more costly, because first going for the small factory and then upgrading this factory in the future to a bigger one is much more work intensive than going for the big factory immediately. So in this situation, the outcome of our decisions depends on the future demand. That is, we have uncertainty, and we can only try to forecast this demand. And of course, some of the decisions are sequential and are interdependent. So what is a decision tree? A decision tree is a diagram that models alternative outcome. So the most important components of a decision tree are decision points. A decision point is represented by a square. So we draw this as a square, and this is a point in time when a decision is made. Then we have decision alternatives, two or more options that are mutually exclusive. So we can either go for option 1 or for option 2, but we cannot go for both of them at the same time. These are usually represented as arrows that leaves the square, the decision point. We have chance events, and this is an event that has a kind of probability that affects the value of a decision. The sum of the probabilities of all chance events are 100% by definition, and we draw this as a circle with outgoing arrows. In our capacity example, the probability could be the future demand. For example, we have a probability of 70% of a low future demand and a probability of 30% of a high future demand. Together, that's 100%. And we have an outcome in our decision tree. Each alternative has a different outcome, which is usually a number. Yeah? What is the outcome of going for a small factory or a big factory? What is the impact on the profit? This is the outcome. So how do we draw a decision tree? For this lecture, we try to do it always from left to right. The squares indicate decisions, circles indicate chance events, and as I've already told you, the sum of the chance events should be 100%. We write them in parentheses, and we draw the outcome of each alternative near a chance event. You can see this on the example that I'm going to present to you now.